analog to digital. So in this lesson, we're going to look at the basic learning outcome. By the end of the lesson, students should be able to research and discuss technological application of physics in terms of scientific, societal, and environmental impact. So it's looking at how physics has impacted on science, on society, and the environment. So it's looking at students being able to research these topics. So what I'm going to do is I'm going to look through an example. Now there's loads of examples. There's loads of different areas in relation to how like to look at the technological applications of physics. It's all around us in the modern world. But we're going to look at some examples just to kind of give you an idea of what this is about. So one massive area, and it's an area that we've spent a bit of time focusing on, is the whole area of electronics. So at the moment, there's a huge race that's going on. Information is key, and basically what's happening is there's two, if you like, there's two worlds. Okay, so we have our real world, which we can classify as analog, and then we have this growing digital world that's growing up all around us, and it's becoming more and more prevalent as technology improves. And this is this new digital world is a direct result of physics and scientists better understanding how certain areas of physics works. So, and a way to kind of compare these two is to compare. So you can think about the real world is analog, and this new digital area is digital. And we can look at analog and digital like this. So analog basically has this type of it produces graphs with information presented like this. It's kind of like these smooth waves. Whereas digital, it has these kind of like box-shaped waves as well over like time. Okay, so this is, and we want to kind of look at these now in a little bit more detail. So essentially what's been happening over the last like 10 years is we are taking the real world, which is basically analog, and we are translating it into digital. So if we kind of look at some examples of that. So if we take, for example, the first really good example of that is the written word. So if we take, for example, a book and words, and what we have here is a library that's full of books. So modern technology and our understanding of electronics and our understanding of physics has enabled us to take all of this information that's stored in libraries and books like this and condense it down into a digital device like this, okay, like a Kindle. So basically at the touch of a button, you have access to vast libraries of information and books and huge amounts of information. So another area as well is if we think about, so for example, if we think about sound, so if we think about music, so again, at a voice command or at the touch of a button, you can have access to any kind of music that you want. Also as well, you can have access to, if we take, for example, the rainforest, so you don't have to go out into the rainforest and to hear the sounds of, let's say, different animals that are in the rainforest, you can actually at the touch of a button or at a voice command, you can easily get that information. So it's taken music, for example, or sounds that are in the environment that are picked up by the environment and being able to translate that into a digital form and then being able to use a technology to make that transition. So if we take, for example, Alexa, so you have these digital devices that that you can give it a voice command and it'll basically bring up any kind of, pretty much any information that's on the internet, it can bring it up for you. So again, there's a whole process of taking this real world, for example, real world sounds, and translating it into a digital form and then being able to put it into a device like this. Also then as well, if you take, for example, images, so if we take images, so this is an image of a rare frog that was just discovered in the past year, and this image is made available all around the world and to scientists and biologists all over the world at the touch of a button. And we have it here as well. Even this technology that we're using to make the lesson today is all a direct result of this better understanding of physics and being able to go from analog to real world to digital into this digital world that we're using even right now as we as you listen to this lesson. So again, it's been able to take something like, for example, light that's in the real world and translate that into a code, if you like, that computers can understand. So when we say that the world, for example, is analog, what we mean is that, and we're going to look at this in more detail, if we think about, so what is the written word? Essentially what the written word is, it's light. So you have light that's been reflected off a text, it's going into your eye, your brain then is able to interpret that, compute it, and make sense of what it is that you're looking at, and you're able to process that, for example, with your mind. If we take like sounds, for example, so sounds from animals in a rainforest, like again, what are they? They are vibrations, so they are vibrations in the air. And you can think about light, for example, and sound as like, you can think about them as waves, and they have this kind of wave nature to them. They have an analog wave nature to them. Now, the real world is extremely complex and it has huge amounts of information and data. So, being able to take this information and translate it into digital so that it can be put onto a device is the whole domain of electronics and computing and computer science and computer programming. And that's what it's all about. So, essentially, what you have is you have this process that's happening. So, you have, for example, an analog signal. So, you can think about sights or sounds or information from textbooks, as you can think about it as analog signals. So it's like a signal that is emitted, if you like, from these types of things that are in the real world. So that signal then, it has to be translated into a digital signal. Okay, so digital is what computers understand, and that's what goes on inside the computer and makes the computer work or makes the device work. And then in order for humans then to be able to understand and to be able to communicate with computers, it then has to be put back out as an analog signal. So, for example, it will be displayed on a screen, it'll be played as a sound, but the gap in between that, so from going from taking objects that are in the real world, which are analog, translating them into a form that computers can understand and process and store, and then computers being able to give them back to us in the language that we understand, analog. Um, this is the whole domain of electronics and computer science. So slowly and progressively, the real world is being translated into a digital world. And that's evident even in the world around us. Even today, you can, for example, use an Oculus Quest and you have a whole virtual world in there that is growing constantly all the time as well. So this is a huge development, if you like. You can call it the information age that we're currently in at the moment. And this is a direct result of science, and it's a direct result of scientists, particularly physicists, being able to understand the nature of the world around us, in particular, light and sound, and being able to understand electronics, electricity, and how those things work, and then how engineers then can take that information and build devices like this is just a handful of devices that we have now that is in a massive way transforming the world. So we're essentially going from analog to digital. So to better understand this, let's think about what exactly analog is in relation to the world that's around us, in relation to these examples. So again, we're talking about light, understanding what light is, and then understanding what sound is as well, and then being able to translate that into a language that computers actually understand. So essentially, if we take light, so basically light is what's called electromagnetic radiation. So it's essentially a wave. And light that we see is in a very narrow band. Okay, it's called the visible spectrum. And it's a spectrum basically that you can see here, you have basically all the colors of the rainbow. And light is a wave. And we're going to look at what waves are and the properties of waves. So the same with sound then as well. So sound is also a wave. So you can think about, in order for sound to travel, it needs a medium like air to travel through, or it needs, for example, water, or it needs a solid object to be able to to be able to move through. And essentially what it is it's like a compression and then a decompression and compression of the air particles or water particles or solid particles that are around, and it follows this wave form or this analog form. Okay, the same with light as well. And on this electromagnetic spectrum, you have other things like, for example, radio waves. So in the world around us right now, we are like electromagnetic radiation is passing through us and around us and in the room all the time. And what we're able to do is we're able to take this signal. So for example, if we take the light that makes up the object that is reflected off the objects or emitted by the objects that are in the room, and we're able to take a picture and turn that into a digital picture and then put it onto, for example, a Kindle, or put it onto a mobile phone, or even put it into a virtual reality headset. Or we're able to take sound, for example, and record that sound and put it into a device like an Alexa. So what we're doing is we're taking an analog signal from the world, from reality, if you like, and we're translating it into a digital signal. So we are that a computer can understand and that a computer can process. So let's focus on the characteristics of light and sound. So as I said, light and sound, you can think about them, they are what are called waves. So this is like this is a wave. So if we think about it, we start off, so for example, there's no wave, so everything is at rest. And then what happens is the wave starts to propagate. And what you have is you get a crest, which is the top peak, and then you have a trough, which is the bottom peak. Okay, and then you're going to have another crest and then another trough. And what you have is you have these things called wavelengths. So the wavelength is basically if you measure between the crest of one wave over to the crest of the next wave. And that's what's known as the wavelength. And that's what distinguishes waves from each other. It's the wavelength. Also then as well, you have this thing called amplitude as well, which is basically the height of the wave. Okay, so again, waves can have different wavelengths and then they can have different heights as well. Also then as well, we have this thing what's called frequency. So basically frequency is like a cycle. So it's basically the number of waves that passes a point every second. Okay, so that's what's known as this thing called frequency, and we use hertz to measure frequency. So if we have a look at this then, so what we have here is we look at this in a little bit more detail. So we have essentially the real world. Okay, it's full of light. Okay, so everything around us gives off color, and in order for us to be able to see, we need light in order to hit our eyes, in order for us to be able to see. Now, light is a very interesting substance as well. It travels, as I say, it travels as this what's called electromagnetic radiation. So electromagnetic radiation. And there's all different types. So this whole thing here is what's called the electromagnetic spectrum. So essentially what you have is you have different electromagnetic radiation that has different wavelengths. So we can see here that down here on this side you have very short wavelengths, whereas up this side you have very long wavelengths. And that's what kind of distinguishes one type of wave, electromagnetic radiation, from another. And what's really interesting is that if we take up here on this side, so you have, for example, radio waves. So these would be waves that would be used to generate sound, for example, in radios. And if you think about, if you have a look at their wavelengths, okay, so from here to here, it goes from 1 meter wavelengths up to 10 to the power of 3 meters wavelengths. Okay, so you have these huge big waves. Then they have massive wavelengths. Then if we go down to the other side completely, you have, if you take, for example, an X-ray, so when you go in and you get an X-ray, essentially what they're doing is they're bombarding your body with electromagnetic radiation, and this electromagnetic radiation has really small wavelengths, okay, in comparison to, for example, radio waves. And that And also as well, what, as you can see, as we move up here, so you have this what's called hertz. Okay, so as you move down here to this side, what happens is the electromagnetic radiation carries an awful lot of energy. Okay, so it carries like an energy with it that that can be damaging. So if you take, for example, gamma rays have, they're very low, small wavelengths, but they have very high frequency. And what they do is they can do serious damage. For example, to a person, they can like damage cells and things inside a person's body, and so can X-rays as well, because of this what's called a high frequency. It carries a lot of energy. Whereas if we take then like our whole visual field is wired, if you like, our eyes are set up to detect just this small band of electromagnetic radiation, and that's what we see as everything that we can see with our visual system. And like the wavelengths are extremely small, so they are, and you have different frequencies of visible light. So this is what's called visible light, and our eyes are able to detect this and we're able to see it. And that's what, when we look around and we see all the color in the world around us, essentially what we're looking at is electromagnetic radiation from the visible spectrum. So because physicists have spent a long time understanding this, like what electromagnetic radiation is and how it works, we have a very good grasp of how it works. And what we're able to do then is we're able to build all kinds of technologies based on our understanding of this electromagnetic radiation. Also as well, electromagnetic radiation is so if you take the sun, for example, so the sun is in the depths of space, it's millions of miles away, and it doesn't need a medium to pass through, so it can literally pass through what's called a vacuum. So in order for the light from the sun to get to the earth, it has to pass through the vacuum of space, and then it gets to the earth. And that's really important. If that didn't happen, there would be no life as we know it on the earth. Okay, so you have a vacuum in space, and light is actually able to move through that. And essentially what happens is, if you take an object, let's say for example let's say you have like a red cube like this. So the cube is made up of matter, and essentially what happens is, if we think about matter, matter has electrons. So the light from the sun hits the cube, and what it does is it excites the electrons in the atoms that make up the cube. So imagine the electron is down here like this, and then it gets some sunlight, and what will happen is it'll go up into a higher state, and then it'll come back down, and when it comes back down, it emits a wavelength from the visible spectrum. So depending on how high the electron goes up and how far it has to travel back down again before it emits the light, it'll emit different wavelengths of light, and that's what corresponds to the different colors that we see around us. And so scientists understand this, and they understand how it works. So if we take, for example, the color red, we're getting light being emitted, that's being emitted from this band here, if you like, for the wavelength. And this is what light is. So essentially when you look around, you see color in the room around you, what's happening is light from the sun or from an artificial source is exciting the electrons that are in the atoms that make up the objects around you. The electrons are getting excited, they're going into a high energy level, they're coming back down, and then they're giving off this electromagnetic radiation, or they're giving off light essentially. So they are. And we humans understand like how light travels. So light also is the fastest thing in the universe. It travels extremely fast. That's why when you open your eyes, it's instant that you see, for example, light. But every second, every time you look around the room, what's happening is, so this is your eye. You have electromagnetic radiation that's going into your eye, and it's stimulating an optic nerve in your eye that's going to your brain. Imagine this is your brain. And then your brain then interprets that. Your brain is like a computer, it interprets that and it creates the color that you see in front of you, for example, red or whatever the color is. So that is light, for example. And if we think about think about if you lost your sight, for example, you would not be able to see colors, or you wouldn't be using light as much as as you do now. And again, these are the characteristics of a wave, and we have this thing called hertz, which is like the number of cycles. If you were to stand here and there was light passing along, and you're able to measure, for example, the number of wavelengths that pass through every second. That's what we mean by the cycle. So then the other thing then, so think about then, like that's our understanding of that enables us to take visual objects and translate them into digital forms or digital formats that we can then use on devices. Then we have sound. So again, sound is an analog wave as well. So it has this shape, if you like. And again, essentially what sound, now the difference in sound and light, sound needs a medium to pass through. So essentially when you have like the air, so what happens is, imagine, so this is all air here. And what happens is, imagine, so you have a speaker here like this, and the speaker vibrates. And what it does is it compresses parts of the air, and then other parts are not compressed. And what happens is the wave passes through the air like this. Okay, so you get this compression and contraction. And this essentially is what you see here. So every peak is a compression, and then every trough is like where it decompresses. And essentially what happens then is that this wave, if you like, of compressed and decompressed air passes through the environment that you're in. It hits your eardrum, and then that sends a signal to your brain, and then your brain interprets that as a sound. Okay, and then it puts a perception on it. So again, what's interesting as well is that you have this different frequencies of sound. So humans have, we can see, or we can hear, should I say, frequencies from roughly about here to here. And you can see that they all have different wavelengths. So they have, as the wave starts to get compressed and the wavelength gets smaller, your frequency is increasing. So there's only certain frequencies that humans can hear. If you take other animals like whales, for example, spend their time underwater, sound travels through water and they communicate through sound. So again, they can hear sounds they can hear down here in these frequencies that we can't. And then if you take bats then as well, so they can hear in some of our frequencies, but they also can hear much higher frequencies as well. And then also as well, like we have devices then that we can use to pick up and listen to these higher frequencies or lower frequencies as well. So again, this is like light and sound and how they work, and basically that they are waves. So scientists completely have a very good understanding of this, physicists. So as a result of this, they're able to take this information, which is in analog, which is like the real world, and they're able to translate that into a signal that's like this, which is digital. So essentially, computers are digital devices, and their language is binary language. So it's the language of computers. So they store their informations in zeros and ones, okay, which is binary information. And another way to think about it is you can think about like they're like on, it's either on or off. So zero, for example, can be on and then one can be off. So that's the way that's the language that computers use. And because we have a really good understanding of that as well, we're able to build devices like all of the modern technology that uses electronics around us. And essentially, like what computers are electronic circuits, similar to the circuits that we've been looking at, but much smaller and a lot more of them. So as a result of that, we're able to go from analog to digital, and then the digital devices are able to put the information back into analog so that we can interpret it and understand it and interact with it with our senses, with our eyes and with our ears. So this whole area of electronics and where it all came from. So you had different so the whole foundation of this started with this man here, which is called George Boole. So the mathematics for digital electronics is based on the work of George Boole, who was the first professor of mathematics in Cork University, and that was from 1849 to 1864. So his mathematics and what he discovered and developed back in the 1800s is like the bedrock that modern electronics use today. So that understanding really helped to progress the area of electronics and what we have today. So digital electronics has had a great impact on society, and you might call it an electronics revolution. So electronic devices like computers and mobile phones and VR headsets, etc., is completely changing the way the world works and how the world operates. And to help us to discuss and research how digital electronics has affected the world, we will examine the technology associated with this whole area of telecommunications um, and the internet. So we will look at how science, the environment, and society in general have been affected by these technologies. So with the development, with the understanding of the physics and with the understanding of the maths, you have the development of these, like this new era of information, and it's what's known as the electronic revolution. So if the first thing we're going to look at is this idea of what is meant by telecommunications. So think back, imagine a time before there was, for example, telephones or mobile devices. Think about if you wanted to meet up with your friend, what you have to do. Okay, and think about like how difficult it would have been to communicate with somebody if they were in another country, for example. You might have to send a letter, it take a long time for that letter to be delivered, and even it was much more difficult to communicate. So with the development of physics and with our understanding of sound and light and how all of that works and electronics, we started to develop telecommunication devices. So telecommunication devices are your mobile phones and the internet, for example, that allows humans to communicate with each other over vast distances easily. So keeping in touch by telephone has become easier, cheaper, and more reliable in recent years. Uh, and we will consider some short statements on how the following have been affected by new forms of telecommunication. Okay, so we're going to look at like how it has impacted science, how it has impacted the environment, and how it has impacted on society. Okay, so what you have here, so optical fibers have replaced old cables from phones and are much more efficient. So back, you had these dial-up phones before optical cables, and they were very inefficient. So you can think about it like your house, your landline or your house phone is probably built based on this technology. But what has replaced that are these what are called optical fibers. So essentially what an optical fiber is, so optical fibers are essentially, it's like a long piece of glass, okay, strands of glass. And what happens is information can be sent as light. So you get like pulses of light that pass through this glass. And because light is the fastest, like the fastest thing in the universe, that signal, okay, can be sent over long distances extremely quickly. So it's sent over these fiber optic cables. So it basically uses light. So, and that light is used to transfer information from one point to another. So for example, if you are in Ireland and you take a picture on your mobile phone and you text it you post it on Facebook or you send it over to your friend who might be in Australia, for example, what's going to happen is that you're going to take that visual light. Okay, your electronic device is going to take that light and translate it into binary. Okay, and then it's going to be translated then into a signal, and then that signal is going to be sent across a fiber optic cable, and then that signal will be received on the other side by another device, which will turn it using binary. It'll interpret it, and then it'll turn it back into an analog signal. For example, it'll display it as an image on the phone so that your friend can actually see it. So there's this whole like path and network of like technology basically between you and the person that you're contacting, and that is all, everything from start to finish is there because scientists understand, for example, how physics works, how light works, how to manipulate light, and how to use it in order to be able to do something useful, like transfer information over large distances. And these fiber optic cables are way more efficient than older cables that were used, which they didn't use light, they used electricity to transfer information over longer distances, whereas these fiber optic cables are much more efficient. So with the development of these fiber optic cables and telecommunication technology, how has that impacted on science? So the popularity of mobile phones has resulted in greater need for people to be skilled in electronics and computing. Many courses in electronics are offered by universities and third-level colleges. More people today understand and appreciate the wonders of this area of science. So, as a direct result of society wanting to use these telecommunication devices, we need people that understand how they work. And not only do we need people to understand how they work, but we need people to be able to build these devices and even design new devices. And this is the whole area of like computer science and electronics. And it's a massive area that's in huge demand. Like these businesses and industries are constantly looking for people who understand how this stuff works and are able to build it and create new devices, let's say, and research in the future. So again, from a scientific point of view, it has resulted in more people being educated, for example, in how these areas of science work. Before, it might have been a small handful of people that understood how they work, but because these technologies are more available now, more people need to understand how it works, and there are lots more jobs in areas. There are jobs in, like, for example, there are jobs today that wouldn't have been around before the mobile phone was invented. So what does it mean then for the environment? Now, many modern electronic devices become outdated very quickly. Outdated devices are dumped or recycled, and newer devices are manufactured. Now, in order to manufacture devices, you're using Earth's natural resources that are being used up in the manufacturing process, and the waste causes a problem in the environment. So the problem has also led to a greater awareness of the need to recycle, and the copper and old wiring is very often recycled as well. So what happens then is, like, because there's so much technology being produced and it gets updated and it's replaced with newer devices, you end up with a lot of waste like this. So it's very important that we are able to recycle this waste and use it again, or we're able to build devices that are more efficient. But again, there's a demand for natural resources to build and power these devices as well. And then if we think from a society's point of view, like, how has telecommunications impacted on society? So think about if you didn't have your mobile phone for a week, what that's like. So instead of walking or cycling to a friend's house, people today choose to text or use social media from the comfort of home. So it's easy to keep in contact with people and see how they are and how they're doing. Are people becoming lazier? How will this lack of exercise affect a person's health as they get older? Many young adults move to foreign countries after they finish their education. With the improvement in communication technologies, they can keep in contact with their parents and friends back home on a regular basis, and this is very comforting to the young person and their family when, for example, a young person moves abroad. So mobile phones, you will be very familiar with them and their uses, so think about how useful they are, and in order for those devices to be even in your hand and you've been able to use them, somebody needs to understand the physics and the electronics and the computer science that makes these objects work. So is the ease with which we can keep in touch with people making us lazy? So the other side of it too is that it does have a massive impact. Like, are people then becoming more isolated because of technology? So they're behind screens as opposed to meeting people in person. So again, you have to kind of look at it from that point of view as well. You have this knock-on effect from these technologies. So the next thing I want to look at is the internet. So the internet is a vast worldwide network of computers all connected together. The table below will show how the internet has influenced the lives of people. So if we think about, like, over the years, and this isn't even up to date for today's date, but over the years, if we have a look, what's happening is you have more and more electronic devices are becoming available for people, and as a result, you have more and more people plugged into the worldwide network. And as a result of that, the number of people using the internet is massively grown over the years. And in some ways, it's a good thing and it's a bad thing. But what it does is it means that there's more demand for these electronic devices. So in order for to keep up with that demand, we need that skill set of people who understand how they work and are able to build them and fix them and program them and research new versions of these devices as well. But what we can see is so from 1995 to 2019, you can see that there's a huge growth in the number of people using the internet. So consider the following short statements and how the internet has affected each of the following areas. So we're going to look at how it impacted science, the environment, and society. So if we think about science, so it has a huge impact on science. The internet gives access to an amazing library with an almost endless supply of information. The study of science has been greatly facilitated by the internet. You can find information and share information with others so easily now. You can study the historical development of science as well as keeping up to date with recent discoveries. So the internet, you can think about it as it's like an infinite library. And literally, there is so much information available at your fingertips. And that was not always the case. There was a time when the internet wasn't around. In order to get some certain types of information, it was very difficult. Whereas now it's literally at the end of your fingertips. You can educate yourself on almost anything through the internet. So from a scientific point of view, it means that scientists can communicate their ideas much more easily with a bigger audience, and they can also share ideas with each other as well. And it just makes collaboration, which is a key part of science, makes it much easier. Scientists now can work in huge global teams and work together on particular scientific questions. So the environment. What are some of the effects that it's had on the environment? The internet has made it very easy to learn about what is happening all around the world. An example of a benefit of this is the idea of renting bicycles to travel around a city. So one city started this, and in a short time, cities all around the world were copying this clever idea. And this had resulted in cities being less polluted and commuters becoming fitter as well. So for example, now, because we're so connected in with other people and other cities and countries all over the world, we're now kind of open up to their ideas, and we can also look at implementing their ideas, for example, in this country as well. So that can have a positive impact in the environment, like if we take initiatives like this initiative here, things like that can help us to combat some of the environmental problems that we are facing at the moment. And then just the last piece then is like the internet and society. So more and more now, you do not need to go physically to a shop to buy the things that you want to buy. You can more and more buy them online. And again, that's making more demand for scientists to understand how these technologies work. So many tasks are made easier because of the internet. You can book a holiday, order a book, and buy clothes on the internet. However, the people who worked for the holiday company, the bookshop, and the clothes shop may have lost their jobs. Has the internet been good for society? So there's always that knock-on effect. If you are a person who sells books and you're competing with trying to sell against people who sell things online, it can be much more expensive to try and compete with that. So it has its benefits, but then it also has knock-on effects on people as well. So it has that impact on society. But if you think about now in the information age, like a lot of shopping is done online, and that's facilitated by these electronic devices that we have been talking about. So that is physics and how physical technologies have impacted on society, the internet, or society, science, and also the environment as well. Okay, thank you for listening.